So we're going to begin the lesson. It's titled 7.1, 7.2, and we're going to be talking about the 7 rules of exponents, but today we're focusing on the first 3 of 7. Now let's begin by writing down P, or a B right here and a little p up there. And I hope we remember what this B stands for. What does a B stand for, anybody? Base, right? That B stands for the base. How about that little p up there on the top right corner? What is that? Anybody? Exponent or power, right? Okay. So this is the base, this is the power. I hope we understand that. Now, if you already know that, you don't have to jot it down, but if you're like, well, I kind of remember that, it's a good idea to jot it down, right? If you're not feeling like a pro on this, jot it down, take some good notes, okay? So right now, you should know that the B is the base and the, and the P is the power. Sorry about that. Okay, so what does the exponent actually tell us? The power, also known as exponent, it tells you how many times to multiply the base with itself. So that's like the main part of the notes today. That the power tells you how many times to multiply the base with itself. So if I said 2 to the third power, what that really means is what? To write this base multiplied with itself that many times. So that's really saying 2 times 2 times 2, which is really what? What is 2 times 2? Times 2? 8. So 2 to the third is really 8. Now, this right here is called expanded form. Expanded form. Okay. But the actual answer is 8. Okay. Now we're not going to be showing expanded form. I'm just doing it right now, and I'll do it for sure on the rest of this video on most of the questions, just so you could really get a good understanding of all the different rules that we're going to be talking about. So I hope we understand what an exponent is and how it works. The exponent tells you how many times to multiply the base with itself. So quickly, guys, could you tell me what 5 to the second power is? 25. Cool. 25. And you could say 5 times 5, but 5 times 5 ends up being 25. How about 3 to the second power?
9.
9. Cool. Now, how about 3 with the negative sign in front to the second power? Now, before you answer that, I want you guys to copy that down, and I want you to also copy down this one, parentheses, -3 to the second power. Because there is a big difference here. Parentheses make a huge difference. Okay. The first answer will be, anybody? -9. Okay. Now, here's the true understanding of why the answer is -9. Whenever you have a negative sign in front of anything, technically that means -1 times whatever you have. Okay. So this really means -1 times 3 to the power of 2. I mean, if I said negative x, what does negative x really mean? It means -1 times x. Does everybody agree with that? That a negative sign is really like a -1 times in the front? Okay, good. So right here, it's really saying -1 times 3 to the second power. And when we think -1 times 3 to the second power, we have 2 math operations, multiplication and exponents. And we should all know that multiplication comes after exponents. You do exponents first, then multiplication, right? Okay. So with that reasoning, we should understand that you have to do exponents first before multiplying by -1. So in reality, you have to deal with the 3 squared first, and then deal with the -1 that's being multiplied in the front. So when we do 3 squared first, that's really a 3 times 3, and the negative sign that's in front, you just put it in the front right there. So in a sense, the problem becomes 3 times 3 with the negative in the front. That'll give you a -9 as an answer. Now, if you compare that to this other one right here, where you have -3 in parentheses, then that really is -3 in parentheses times -3 in parentheses. And we all know that a negative times a negative is a positive. Yay? All right. So if I said, what is -2 in parentheses to the third power? Well, that's really a -2 times a negative 2 times a negative 2. And what is a negative 2 times a negative 2? And what is 4 times negative 2? Negative 8. Okay, so it didn't make much of a difference right there if I didn't have parentheses. But a lot of times it does make a difference. So for example, if I said, what is negative 5, no parentheses, to the second power? What's negative 5, no parentheses, to the second power? That's negative in front, and 5 squared. 5 squared is 25. So it's really a negative 25. So that's a little curveball right there. Parentheses do make a difference. When you have, bless you, when you have parentheses, including that with the negative on the inside, then the base truly is a negative number. The base truly is negative 2 times negative 2 times negative 2. But if you don't have parentheses, and it's not including the negative on the inside of parentheses, then it's really 3 squared with the negative in the front. It's really a 5 squared with the negative in the front. So I hope we get that first part of the lesson. This has nothing to do with even the first rule. This is just understanding exponents and how they work, especially with parentheses. Let's actually get to the first rule. The first rule of exponents, rule 1, is if you are multiplying two terms with the same base, then you simply add the exponents and keep the base. Now, if you're jotting down these rules, at the very least, write down rule 1, and then you could say add exponents. Okay, because that's what ultimately happens. You add exponents, but the real thing, you gotta know the whole thing, obviously. When do you add exponents? When you're multiplying two terms with the same base. You see, you got an x squared, you have an x to the third, the x's are the same, you are multiplying, and what do? We just add those exponents and keep the base, x to the fifth. Okay, now this rule is, or just like any formula, it's kind of like a shortcut. A rule is like a shortcut. It's not like some mathematician said, you know what, I'm going to create a rule today, a long time ago. No, it didn't work that way. Mathematicians, what they do is they observe what's happening and then they create a shortcut, or they create a rule. So let me explain what's actually happening here. What is x squared? What is x squared? It's really x times x, right? And what is x to the third? It's really x, it's really x times x times x. And of course you have multiplication between them. So technically you do have x times x times x times x times x. How many x's is that? That's a total of 5. So that's x to the fifth. Now obviously this took a long time to do. So why the heck would we actually do that if they already recognize the shortcut? Just add the 2 and the 3 and you'll get 5. Does that make sense? Okay, so if you understand that, what would x to the fourth times x to the sixth be? X to the 10th, right? Just add them, right? It'd be pointless to say x times x times x, x times x times x times x times x times x, and then add them up. That'd be pointless. Just the rule says when you're multiplying with the same base, add the exponents and you're good to go. Do you get it? I hope so. Let's go over some more examples here. Here is another 2 examples. Go ahead and copy those down. Now there is a slight difference on these because we actually have coefficients. We have numbers out in front. So the beauty about multiplication, when you have pure multiplication, like in reality this says 2 times x to the fourth times 3 times x squared. You have a bunch of multiplication everywhere. And there's this thing called commutative property of multiplication that means you could switch the order and it's okay. 2 times 3 is the same thing as 3 times 2. You could switch the order. So what I'm going to do is just rearrange it. And I normally don't do this, but right now I'm doing it. I'm going to rearrange it. I'm going to put the big number 2, the coefficient 2, times the coefficient 3. And then I'm going to put my x to the fourth and then my x to the second. Normally I don't do this. Normally I do this in my head, but right now I'm showing you how I'm organizing this in my head. And of course, 2 times 3 is what? Those are not exponents. Those are just numbers. What's 2 times 3? 6. Okay, now you could do rule 1, x to the fourth times x to the second. What do you get? X to the sixth, because rule 1 says if you're multiplying with the same term, add exponents. So I would not even actually show this process right here normally. I would just do this in my head. I would say, okay, 2 times 3, that gives me 6. X to the fourth and x to the second, that gives me x to the sixth. because you add those exponents. What would the answer to number 2 be? Anybody? What's the answer to number 2? Okay, keep in mind that the coefficients, this 6 right here, that's a big number 6 times a big number 5. Let's write it out. 6 times 5. What is 6 times 5? 30. So the first part of your answer over here is going to be 30. Now, what about those x's? What x to the 5th times x to the 6th? X to the 5th times x to the 6th. What do I get? X to the 11th. There you go. Right? Rule 1 is really not that difficult. I hope you guys understand it. Just the numbers out in the front, those are just numbers. Those aren't powers. So you're actually going to multiply 6 times 5, 30. Right here, that's a power, same base. That's where you use rule 1, put them together, add them. 5 and 6 is 11. Put them over that same base. Okay? Now, it is true that when you have like x to the 4th times x to the 10th, we add them and we'll get what? X to the 14th. Okay, we understand that. But what if you had x to the 4th times y to the 2nd? Then you cannot add exponents right there. So right there, you just leave it. You would say x to the 4th times y to the 2nd. You just leave it like that, right? Can't add those. Okay, the rule only works if you have the same base. If you're multiplying two terms with the same base. They have to both be x's in order for you to add those exponents. Right here, the bases are different. Can't add those exponents. You just leave it exactly the way it is. Okay. So hopefully we understand that. And I threw that out there because there will be some that have both x's and y's. Here's an example of that. It looks ugly, but it's not. Go ahead and copy that down. It's a nice problem. Now, you're thinking, what the heck? It's all pure multiplication. So there's no addition sign between the 3 and the x squared. There's no minus between the x squared and the y to the 3rd. It's all pure multiplication. There's actually a multiplication sign between the 3 and the x, between the x and the y, between the y and the z, between the z and the 2, between the 2 and the x, and between the x and the z. So what does that mean? I could rearrange this however I want. Now, I would normally do this in my head, but right now I'm just showing you so you won't get confused. I'm actually going to put the 3 and the 2, those coefficients, those regular 3, the regular 3 times regular 2, I'm going to put them together. I'm going to put the regular x squared with that x to the 5th, x squared times x to the 5th, put those together. I'm going to put the y to the 3rd. There are no other y's, so I'm just going to bring that right there, y to the 3rd. And last but not least, this z, which has an invisible exponent of 1, I'm going to put that right here, z to the 1. And this z to the 7th, I'm going to write it right there also. So all I did was rewrite everything, but I rearranged everything so I could have the nice numbers in the front, the x's next, the y's, and then the z's at the end. Are you with me? And like I said, normally I would not do this on paper. Normally I would just do this in my head. 3 times 2 is, what's 3 times 2? 6. And then x to the 2nd times x to the 5th, I add the 2 and the 5 together. What do I get? 7. And then the y to the 3rd, there's nothing to add it with, so you just bring it down. And the z to the what? 8. There you go. What do you think? Rule 1's not that bad. Question. I got the exponent 7 by adding the 2 and the 5. Because the rule says when you have the same base and you're multiplying, add the exponents. Okay? So again, start with your big numbers. 3 times 2 is 6. And then go on to your x's. You want everything in alphabetical order, x, y, z. Start with x's. X squared and x to the 5th. That's x to the 7th. Y to the 3rd, there are no other y's. So y to the 3rd, just bring it down. Z to the 1, z to the 7th. Add 1 plus 7, you'll get z to the 8th. That's rule 1. Okay. Let's move on to rule number 2. Rule 2. So this one is fun. Actually, all these are fun. I like this chapter. If I were you, I would write down rule 2 of exponents. And it's just simple. Power to a power, multiply. That's simple. Power to a power, multiply. Now, of course, if you want to copy down everything, go for it. If you have a power to a power, then multiply the exponents and keep the base. Okay? So as you can see, we have x to the 2nd, to the 3rd. The answer is already here for us. It's provided. This is not an equation. So again, the way I would ask this on a quiz would be like this. What is x to the 2nd, to the 3rd? Oh, power to a power, multiply. That's how you get the answer x to the 6th. Okay? Now, the rule, it came from a mathematician creating a shortcut. A shortcut to what? Well, let me try to explain that shortcut. It started out with the base being x squared in parentheses to the third power. That third power tells you what? That you're going to multiply this base with itself how many times? Come on, people, wake up. I'm going to multiply this base with itself how many times? 3. So I'm going to write it x squared times x squared times x squared. So each of these red x squares, what they actually mean, x squared is x times x. X squared is x times x. X squared is x times x. So if you added them all up, x times x times x times x times x times x, that's going to be a total of 6. So x to the 6th. So that's where the rule came from, because, I mean, look at all this work. I mean, that's a bunch of nonsense. The observation that mathematicians did is, oh, power to a power. Instead of doing all this work, just multiply them. 2 times 3 is 6, done. You like it? I hope so. Okay. Let's actually do some examples where you have a power to a power and you multiply. Check it out. So number 1, x to the 7th to the 8th. Please copy that down and let's write the answer. What is the answer going to be? X to the 56th power. Nice and simple, right? Just multiply 7 times 8, get 56, you're done. How about the other one? 2 to the 3rd to the 2nd. Well, we don't have x this time, we have 2's, right? 2 to the 6th power. Okay, now that is the answer, 2 to the 6th. But anytime in math, if you could actually do something else, anytime you could simplify something, simplify it. So let's ask ourselves, what does 2 to the 6th actually mean? It actually means 2 times 2 times 2 times 2 times 2 times 2, 6 times on. And if we think about this, 2 times 2 is what?
4.
Times 2?
6.
4 times 2 is 8, and then 8 times 2, 16 times 2, 32 times 2, so it's actually 64. So 2 to the 6th is really 64. Okay, and of course I only did that because I could actually do 2 to the 6th. If it were x to the 6th, I would have just left it like that. So I hope we understand. Now this last one is, I actually messed up on this because I gave the answer, I think. So let's just think about this before I show you the answer. X to the 5th to the 3rd to the 2nd. Power to a power to a power. You multiply those powers. What do you get? Final answer is x to the 30th. That's right. X to the 30th. Okay? And it doesn't matter if you're multiplying 5 times 3, you get 15. 15 times 2, you get 30. Or 3 times 2 is 6. 6 times 5, you get 30. Bottom line is you are multiplying all those exponents. Do we understand rule number 2? Shall we try one more? Yes, please do one more. Okay, what if we had, let's say, x to the 2nd to the 4th to the 10th. What the heck? What's the answer there? Come on, people. X to the what? X to the 80. See? It's easy, right? Okay, so rule 1, when you're multiplying two terms with the same base, add the exponents. Rule 2, when you have a power to a power, multiply the exponents. Are you ready for rule 3? It's more fun than rule 1 and 2. Here it is. And technically, rule 3 is rule 4. Okay, but I don't want to confuse you. We're going to do rule 4 tomorrow. Let me just move this to the side right here. Right now, what I would like you to do is copy down, say, rule 3. And if you want to be minimal, at the very least, write down distribute exponent. Rule 3 is distribute exponent. But of course, you got to understand the whole thing. So let's read through it and understand it. If you have parentheses with an exponent on the outside of the parentheses, okay, so look, this is a problem. You have parentheses with an exponent on the outside. By the way, I gave you the answer here, all right? So pretend that you don't see the answer here. Pretend that you don't see it, okay? So you have parentheses with an exponent on the outside, okay? So what do? It says, if you have parentheses with an exponent on the outside of the parentheses and pure multiplication or division on the inside of the parentheses. Notice there is no plus sign. There is no minus sign in here, right? If it said 2x squared plus yz to the 5th, you cannot distribute the exponent. If you have pure multiplication or division, you could distribute from the outside of the exponent to the inside, to each inside exponent. That's what it should say. So this 3, if you're copying it down, circle the 3 and distribute that power to the power of 2. Now there's an invisible power on 2, which is a power of 1. So when I distribute the 3 to that power of 1, power to a power multiply, you will get 2 to the what power? 2 to the third power. And then we're going to have x to the, we distribute that 3 to the 2. What's 3 times 2? 6. So x to the 6th. And then we distribute the 3 to the y, and the y originally has an invisible 1 right there. So this is going to be a y to the what? Y to the third power. And last but not least, the z, when I distribute that 3 to that power of 5, power to a power multiply, that's what rule 2 is, z to the what? 15th. Excellent. And there's your answer. However, the only other thing you could do is actually work out 2 to the third. 2 to the third is not 6. What's 2 to the third? 8, right? 2 times 2 is 4, times 2 is 8. So that's how we get this final answer right here. So this rule is actually pretty simple. Rule 3 is where you distribute the outside exponent to each inside exponent. You distribute the outside exponent to each inside exponent. But that can only happen if you have pure multiplication or division on the inside. No addition, no subtraction. Okay? Let's do a couple more examples. Jot those down, please. Now, some people will think that the answer here is 2x to the 6th, and that's incorrect. Because we actually have an invisible 1 on the 2, an invisible power of 1 on the 2. We have parentheses with an exponent on the outside. That outside exponent needs to get distributed to both exponents on the inside. And of course, when we distribute, we multiply, right? Power to a power multiply. So what do I end up with? Instead of 2 to the 1, I end up with 2 to the what? 2 to the 3. That's right. And instead of x squared, I end up with x to the what? 6, because you multiply 2 times 3, you get 6. Good job. And now, could I do 2 to the third? Yeah, 2 to the third is what? 2 to the third is 2 times 2 times 2, 8. And then the x to the 6 stays, and there's your final answer for that first extra example that we just did. How about that second one? Take that 3, distribute it to each and every exponent, and they're all invisible 1s. So my answer is going to be, instead of 2, it's going to be 2 to the third, x to the third, y to the third, z to the third. And the only other thing you could do is actually this number right here, 2 to the third. What is 2 to the third? 8. X to the third, y to the third, z to the third. So rule 3 is pretty easy, right? Anytime you have parentheses with an exponent on the outside, distribute that outside exponent to each exponent on the inside. Okay? Now, the reason why this says rules 3 and 4 is because tomorrow's rule 4 is actually the same thing as today's rule 3. The only difference is when you look at it, you're going to have something like this, where you have parentheses with an exponent on the outside, but you have a fraction on the inside, but still there is no addition or subtraction going on, and you would just, tomorrow on rule 4, you're just going to distribute that here, there, on the 2, and on the 5, and then you get your answer by distributing. Same thing as we're doing today. Anyway, those are the 3 rules, right? So I'm going to end this lesson. Tomorrow we're going to start another video explaining the other half of the rules of exponents, rules 4, which is the same as 3, 5, 6, 7. So we're going to do those tomorrow.